Okay, so if I'm looking at 4, 4 is just pretty much checking to see if you know what these different things are saying. So it says, which graph best represents the position of a particle as a function of time if the velocity and acceleration are both positive. So if the velocity is positive, velocity is the same thing as the first derivative. So we're trying to find when the first derivative is positive. And acceleration being positive, the acceleration is the same thing as your second derivative, or the derivative of velocity, and it's saying that that's greater than 0. So if we're trying to find when the first derivative is greater than 0 and the second derivative is greater than 0, if we think of those first derivative test and second derivative test, the first derivative is greater than 0, that tells us that the function is increasing. And when the second derivative is greater than 0, that means that the function is concave up. So when we're looking at these graphs, do you see how this is the only one that's both increasing and concave up? Does that make sense? Okay. So that's all that one is. Then 5, the velocity moves along the y-axis is given here. It moves upward until it reaches the origin. Now some people think of the origin as 0, 0 because that's what you've been taught like all the way through, right? When it's talking about the origin and we're talking about velocity and acceleration and position, the origin is when the position is 0. So when you see reaches the origin, all that means is this right here, the position equals 0, okay? So let's see, it moves upward until the position is 0, and then it moves downward. The position of the particle at any time t is given by which one of these? So if we're given the velocity, and we're trying to figure out what the position is, you have to take the antiderivative and go back a step. So that's what I was doing from here to here. Okay, so our velocity is 8. The antiderivative would be 8t. And then minus 2t, this, if I did the antiderivative, we'd have the minus 2, and then the t would turn into t squared over 2, so it just turns into a minus t squared. And then, of course, you got your plus c in the back. Is that all making sense there, Jane? Okay, so we get there, and then it says, let's see here, there's kind of something that's hidden in this problem that's super easy to like miss, because it's like, wait, how do I have any idea to plug 0 in for the position and plug 4 in for t? Because it doesn't, yeah, it doesn't say anything about that. So I kind of wrote it over here, but this is one of the things, like if you're in a physics class or something too, it's one of the things you have to like pull from the problem that they're not like outright saying, but if you think about how things move, if it moves up and then it moves down, it's going to have to stop at the top. So just a second here. Okay, so this over here, if you think about like something moving up and moving down, we're not thinking of like tossing a ball and it's like going up like a parabola and coming down. It's like going straight up and then it stops and then it comes down, okay? So when it reaches that peak, it's got to like stop, like physically stop for it to move the other direction. So that would be when the velocity here is equal to 0. So I said switches from upward to downward when the velocity equals 0. Does that make sense? Goes up, it stops for, no time at all, but then it comes back down. So what I did is I took this velocity and I set it equal to 0, and then I found that that happened at t equals 4. Is that making sense now? And so then we plug 4 in for our time, and that's when our position is 0, because that's when it reaches the origin. And then once you plug this in, do you see how you can solve it? And once you have your c value, then you've got your answer there. So I'll give you a minute or a moment there to finish that one, then we'll look at the next. All right, slope field for the differential equation will have horizontal segments. So horizontal segments would be when, well, that's not super horizontal, but you get the idea. It's when the slope is equal to 0, right? And if you're saying slope is equal to 0, that's the same thing as saying the derivative is equal to 0. Okay, go ahead. So if the derivative equals 0, That would be when the numerator would be 0, because a fraction equals 0 when the top is 0, okay? So that's what I wrote out to start with, is I took that numerator and set it equal to 0. And then we could take an x and a y out of both of those, so we'd be left with just x plus y in the parentheses equals 0. So you could set this to 0, and you can set this to 0. So either x is 0, y is 0, or x plus y equals 0, which would mean that x would be the opposite of y, or y would be the opposite of x. So when we look at these, you see how this one gives all of those for an answer. Does that make sense? Okay. And then 9 part C was the next question here. So consider the differential equation, write an equation of the particular solution. So we're trying to separate the variables and then take the integral of both sides. So I'm going to take the dx and times it over here first. And then to get the y's together, I would have to divide both sides by y squared. So we would have 1 over y squared dy equals x dx. That look okay to you? And I would probably, for taking the antiderivative, I think it's easier, instead of doing 1 over y squared, writing it as y to the negative second. It's the same thing, so it doesn't matter which way you write it, it's up to you. But I would start with that. So that there will just get you a point, because you separated them correctly. Then I throw an integral in the front of each.
Gabe Groom, please stop in the office. Gabe Groom, please stop in the office.
And to do the antiderivative here, we add 1 to that, so we'd get y to the negative first. Then we divide by -1, which is the same as just throwing a negative in the front. And then x is going to turn into a half x squared, and then we're going to have a plus c in the back. Making sense? Okay, then I'm going to try to solve for y before I do anything with this initial point. I think it's easier, or we don't mess up so much doing it this way. So this is the same as -1 over y. And I'm actually going to multiply by a negative at the same time here, because why not? So that'll get rid of the minus that's out front. So this would turn into negative a half x squared minus c, or plus a new constant if you want to do that. And then I'd times both sides by y. So now I've got 1 equals y times this. Whoops, I missed my negative. And then to get y by itself, I'd divide this over. Stop me if you got a question there, if you need me to slow down. So I'm just solving to get y by itself. So do you see why I'm not like distributing the y through each piece? Because if I want to get y by itself, I would want it factored out so I can divide by that, parenthesis chunk. So really now what we have is y equals 1 over this here.
Could you leave it like before you multiply the y over? You plug in 1 and 2?
You can plug this in at any point in time and solve for your c. But a lot of times they're going to give you a point at the end for getting the y by itself. And I think it's easier to solve it first and then solve for the plus c. We end up with less errors is what I've noticed. It seems like otherwise sometimes, and it depends on the type of differential equation we're dealing with, but certain differential equations, it's super easy to end up with like a positive and it should have been a negative, and I find that if I have people solve for y first, it kind of keeps that from happening. So I'm going to go like this then. But yeah, you might have solved for your c at a different spot, which is all right. I just know sometimes, depending on the type of differential equation, it gets a little bit messed up. And you could leave it like this. Chances are, if it was like I'm looking at a key, they probably times top and bottom by...
Gabriel Groom, please stop in the office. Gabriel Groom, please stop in the office.
Maybe if she adds his middle name in, he'll come down. She's like lengthening his name as she goes. So I might multiply top and bottom by 2 or multiply top and bottom by -2, or we could leave it like this and try to solve for the c and just plug it in. That's totally up to you. If I'm thinking of like what you might see on a multiple choice, I would say I would multiply top and bottom by -2. But because this is free response, that's kind of up to you, okay? So if I times top and bottom by -2, the top is just -2. And the bottom, do you see how the -2 will cancel with this? So we just get x squared plus 2c. Does that make sense what I got there? And then I'm going to plug in this point here. So if I'm plugging 2 in for y, I get 2 equals, and 1 in for x. Just plugging in this green equation down here. See what I got there? Then I'd times both sides by that denominator, the 1 plus 2c. So this left side, if I distribute the 2 through, 2 plus 4c equals -2. And then I'm going to solve for c. And then divide by 4. And then I just want to rewrite this with that c value plugged in. So I'm getting y equals -2 over x squared minus 2, because our c is -1. Hopefully that matches the key there. Does that look okay? I'll check the key while you see if you have any questions on that. Yeah, and the key has it, instead of times them by -2 here, it was just times by +2, so it looks a little bit different. We would end up with the exact same answer if we times the top and bottom by -1. But really, it's up to you how you write it when it's a free response, as long as it's written accurately. Like, it's equivalent, it's an equivalent form, you're good. Okay, and then to the next one here. Okay, so 5, you had a question on part C. Okay, and just the domain part of it, it looks like. So consider this differential equation, the particular solution. Okay, so I'm going to write my dy dx equals x over y. Okay, so if we cross multiply, we get y dy equals x dx. And then integral both sides, and it sounds like you got this stuff worked out. Alright, then I'm going to try to get the y by itself, so I'm going to times everything by 2. So that'll give me a y squared equals x squared plus a new constant. I'll just call it 2c to keep it simple. And then when I square root, it's plus or minus the square root of x squared plus 2c. You following okay? Okay, then if I plug this in, this is where I think it's easier if we tried to plug in up here, you're going to get a c value, and then you're not going to deal with that plus or minus here. So here's like a perfect example of waiting to plug in. It's going to keep you from making an error that you would have made. So if I plug -1 in for the y, do you see how this would have to be a negative out front of the square root so that they would be negative on both sides? So I know it's not going to be plus or minus, it's just going to be the minus piece of it. And then I'm plugging 3 in for x. So if I plug 3 in for x, this would be 9 plus 2c. Then I can just multiply both sides by -1. So that'd turn it into a positive. And then to get rid of the square root, I square both sides. Alright, so now I'm at 1 equals 9 plus 2c. Subtract 9. -8 equals 2c. Divide by 2. And I'm at c equals -4. So then we can go back to here and we can replace it with negative out front, x squared minus 8. And then there's just a domain piece to it is what you're saying that was really confusing you?
Yeah, because I plug in the value before,
Oh,
so then I get confused.
yeah, and if you plug it in early, like, I mean, technically it's fine, but then you have to really think about where this point's located. The point's located 3 to the right and 1 down, so it's actually the bottom half of this, you know, parabola thing that's going on. So that's, yeah, that's why. But I feel like if you wait, it just keeps it simpler. It keeps it so you don't have to think so much about the technicalities of the problem because it fixes it for you. Let's see here. I'm just glancing at the key to see what I just want to make sure that I'm not missing any parts that you might have a question on there. Okay, so, oh, I think I even circled plus or minus. Whatever. It'd technically be the bottom portion of it. If it was multiple choice, it'd have the minus on it. Okay, and then the domain part of it. With the domain, what's true about stuff that's under a square root? It always has to be what? Positive. So this x squared minus 8 has to be greater than 0. And if I'm trying to find where it's greater than 0, first thing I would do is try to find where it's equal to 0. So if I find where this is equal to 0, I'd have x squared equals 8. So x equals plus or minus the square root of 8. And so like at that spot is where we're going to have, you know, something going on. So then I kind of do like what I do with the finding increasing, decreasing, and all that stuff. I put where it's equal to 0. And you could simplify the square root of 8 to like 2 square root of 2 if you wanted. But we could also leave it like this. It's accurate to 3 decimal spots, so it's up to you if you want to go that route. But if I'm trying to find where this is greater than 0, if we pick something between here, do you see how it's negative? So between here, it's actually going to be less than 0. If we plug 0 in, it's not going to work, right? If I plug in something bigger than square root of 8, so like square root of 9 or 3, do you see how that's going to work? That would be a positive. And if I plug in something over here like negative 3, negative 3 when I square it is still going to work. So my domain is going to be from negative infinity to here, and then from here to positive infinity, but this middle chunk won't work. So I would say my domain would go, and domain stuff isn't like a huge part of the AP test, but it is nice to be able to get those questions right when they do show up. And I think in the key I put 2 root 2 instead of square root of 8, but again, it's the same thing. And you don't have to have the u in there. It's okay if you do. It's just saying it's both of these, but if you didn't put the u there, you'd still get the answer right. So that would be the domain that would go with that. And the only reason I'm really worried about the domain
Please staff in the office. Trent Childs, please staff in the
is
office.
because it says state the domain. If it didn't say state the domain, I wouldn't even worry about that aspect of it. Like sometimes on multiple choice, you'll see a domain written in the back. Usually I ignore it unless there's 2 answers that are the same, you know, unless I need to really look into it. It's good to have an idea of how to do it, but it's not a huge thing.